4.5 Limits at infinity. This section is mostly redundant. We have seen almost everything in previous classes or in previous sections. However, we will go over it now just to crystallize these concepts. So the goal is to find limits as x approaches positive or negative infinity, and tied to that is always the notion of horizontal asymptotes. So, first example, describe the end behavior using limits for the function given here. So we have seen that you can use the rule that when you have a polynomial over a polynomial, you compare the degrees, and if the degrees are the same, then you have to take the ratio of the leading coefficient. So here it's 3 over 1. And that means the limit as x approaches infinity is 3 over 1. Likewise, the limit as x approaches negative infinity is also 3 over 1. This is a graph of the function, but of course we didn't need that to answer the question, but it can help now see the kind of function that could have such an end behavior. In the following example, we see an example of where we have this kind of conflict of strengths between exponentials, polynomials, and logarithms. Here, the polynomial is actually a constant function, so it's even easier. You can just think in your head when x becomes greater and greater, the numerator remains at 3, whereas the denominator increases always, so the limit is going to be 0. What happens if we had the limit as x approached negative infinity? Then you would have to think this is 3, and y equals e to the x would approach 0 when x was going toward negative infinity. So the limit, if there was a negative here, would be negative infinity, or in AP Calculus AB, what we always write is dne. Okay. An example here of comparing strengths at the numerator and denominator. Both are polynomials, so this is when we look at the degree, and because the degree is higher at the numerator, we say it's top heavy. That means the numerator is going to win. This infinity is going to grow a lot bigger than that infinity when x increases, so the limit is positive infinity. And again, in AP Calc AB, you would just write dne. In this example, when we look at the range of sin x at the numerator, sin x always varies between -1 and 1. It's this wave, so the numerator is always somewhere between -1 and 1, whereas the denominator is going to increase and increase and increase. So if you imagine a huge value of x, then the numerator is somewhere between 1 and -1 divided by a huge number, so the limit is 0. The graph of this function would kind of oscillate between positive and negative, but become narrower and narrower as it approaches 0. This is a good example of a situation where a function can cross the asymptote. Some students think functions or graphs cannot cross the asymptote. It approaches without touching. Well, this function approaches y equals 0, and it keeps on crossing it. It just gets closer and closer as it crosses it over and over again. Finally, here's an example where we would use L'Hopital as we did in section 8.7. So the limit as x approaches infinity of the square root of x to the 4 minus 1 divided by x cubed minus 1. When we plug in, or when we think about infinity, we would see that we have an indeterminate form, infinity over infinity, and therefore we can apply L'Hopital, which is done here. And after you simplify, you try again, thinking about x approaching infinity, and once again you get infinity over infinity, which means you can apply L'Hopital a second time. And as you do, you finally get to a point where you can plug in well, you can think about what happens. It's 4 over a huge number, so the limit is going to be 0. I did forget to write limit here. You should never forget to write limit in every step. When you find the horizontal asymptote, it's a little bit like in the last example, question D. You want to kind of think of what happens when you plug in a very large number, x, either positive or negative, and see what the value approaches. So we are looking for horizontal asymptotes. That's the same notion as finding the limit as x approaches infinity or negative infinity. So when x approaches positive infinity for this expression, we have e to the negative infinity. You have to have the graph in mind, and you would see that this is going to get closer and closer to 0, and therefore we have 1 divided by almost 1, getting closer and closer to 1. So 1 over 1 is 1. On the other hand, when x approaches negative infinity, now e to the negative infinity is e to the positive infinity, so that grows without bounds, and we have 1 divided by 1 plus infinity, so that is going to be 0. The horizontal asymptote on the left is 0. So that function approaches a different value on the left and on the right. If I can trace with my cursor the graph, it does like this, then it goes up, and then it gets to the second asymptote.